Welcome to the Explainer. Today, we're tackling a massive, kind of invisible problem that is completely dragging down the performance of modern AI coding assistants. Imagine you have a brilliant AI software engineer ready to fix complex bugs and write elegant features. But before it can write a single line of code, it has to spend hours just randomly rummaging through filing cabinets to find where the code actually lives. It gets exhausted, distracted, and honestly confused by all the irrelevant papers it read along the way. Well, that is exactly what's happening to our best coding agents right now. They're getting totally bogged down by reading too much code. So today, we're going to explore a brand new, highly efficient solution from Microsoft designed to cure exactly that. Okay, let's dive right into this. To really appreciate the fix, we got to understand the headache developers are dealing with every single day. We build these incredibly smart large language models. We give them the ability to search through our repositories, and we ask them to fix an issue. But instead of just solving the problem, the agent starts aimlessly clicking around. It opens a file, reads it, realizes it's the wrong file, opens another one, runs a keyword search, gets 1,000 results back, and then tries to read all of those too. It's a slow, bloated process that burns right through your API budget and clogs up the AI's memory. So just how bad is this waste?
Check this out. According to a recent analysis by Microsoft, a staggering 56.2% of all tool-use turns in GPT 5.4 trajectories are wasted purely on reading and searching. Think about that for a second. More than half the time your advanced coding agent takes an action, it isn't writing a fix or running a test. It's literally just looking for things. And every single one of those searches pulls text back into the model's memory, heavily polluting the context window with irrelevant code snippets that just confuse the model when it finally sits down to solve the problem.
So here's our roadmap for today. First, we'll look at the coding agent bottleneck. Then we'll meet FastContext. After that, we'll break down the exploration loop, check out some real-world evaluation results, and finally, wrap up with training and deployment. All right, starting off with part 1, the coding agent bottleneck. Consider this breakdown. A whopping 46.5% of your main agent's total tokens are eaten up just trying to locate relevant code in a repository. It's honestly like hiring a top-tier senior developer and paying them half their salary, literally just to use the search bar in your code editor. Not only is this incredibly expensive, but injecting nearly 50% of irrelevant search noise right into the agent's brain makes it so much harder for it to focus on the actual logic required to write the fix. The root cause here? It's the single agent model. We're expecting one AI to do everything. We want it to be the detective, the reader, and the solver all at once. But there is a much better way, and that's the subagent model. Think of it like a superhero and their sidekick. You've got your brilliant, high-powered hero agent, like a GPT-4 or Claude, who is strictly the solver. And you pair them with a specialized sidekick agent who acts as the scout. The sidekick explores the repository and only brings back the exact files and lines needed. That way, the hero's context stays perfectly clean.
Which brings us to part 2, meet FastContext.
So FastContext is what's known as a repository exploration sub-agent. Let's unpack that for a second. Basically, it's a dedicated, super lightweight AI model that issues read-only searches to return compact file paths and line ranges to your main coding agent. The huge takeaway here is that FastContext doesn't write code. It doesn't tweak your files. The main agent asks it a question, and FastContext just hands back clean, grounded evidence. It basically says, hey, the bug you're looking for is in server.py, lines 45 through 60. No long, confusing trail of failed searches, just the exact context needed. Let's quickly run through the specs for this model family. FastContext sizes range from 4 billion to 30 billion parameters, and they're built on the incredibly strong Qwen 3 family of open weights backbones. But the absolute superpower here is the context length. These models can handle up to 262,000 tokens. That massive window makes it the perfect scout, allowing it to read huge chunks of your repository all at once without forgetting what it's even looking for. Moving right along to part 3, the exploration loop. Now, what's really interesting about this is how methodical the scout actually is. It runs on a tight 4-step loop. Step 1 is query understanding, where it reads the GitHub issue and translates it into a clear search intent. Step 2 is absolutely crucial, parallel tool calling. Instead of searching one by one, it fires off multiple searches at the exact same time to test different hypotheses instantly. Step 3 is observation-driven refinement. It looks at the results of those searches and uses them to guide its very next move. And finally, Step 4, final citations.
It stops exploring and returns those nice, compact file paths and line ranges back to the main agent. To pull off those parallel searches in step 2, FastContext uses a very focused arsenal of just 3 tools. You've got read, which returns the contents of a file along with line numbers. Then there's glob, which allows for path discovery using pattern matching. This is great for finding, say, every single file ending in .py. And finally, grep, which lets the model run rip-grep-style regular expression searches across the whole repository text. And because these tools are strictly read-only, you have total peace of mind that the Scout isn't going to accidentally delete a database or overwrite your code while it's exploring.
All right, let's look at the data in part 4, real-world evaluation results. When they actually plugged FastContext into the mini suite agent framework, the token savings were just wild. With GPT 5.4 on the SWE Bench Pro eval, they saw a 15.9% drop in tokens. But it gets even better. On the SWE QA benchmark, FastContext slashed GPT 5.4's token consumption by an amazing 50.7%. And in some specific cases, that reduction hits 60.3%. You are literally cutting the noise and the cost right in half. And it's not just about saving money. The research is super clear here. FastContext improves end-to-end accuracy for every main agent and benchmark. By handing the solver a completely clean, distraction-free context, resolution rates actually went up by as much as 5.5% on SWE Bench Pro. So you're paying way less for tokens, and you're getting better, more accurate code fixes in return. It's a total win-win. Oh, and here's a really fantastic twist in the data. You'd probably assume you need the giant 30 billion parameter model to get the best scouting results, right? Well, no way. Incredibly, the tiny 4 billion parameter model that was trained using reinforcement learning actually outperformed the 30 billion parameter supervised fine-tuned model. Testing with the GLM 5.1 language model on the SWE Bench Pro benchmark, the little 4B RL model scored a 22.5 resolution rate compared to the 30B's 20.0, and it did that using way fewer tokens. It just goes to show that smart training beats brute force size when you're building specialized agents. Which perfectly sets up part 5, training and deployment. So, how exactly do you train a tiny model to punch that far above its weight class? It's a 3-stage recipe. Stage 1 starts with the raw base model, leveraging the strong foundation of Qwen 3. Stage 2 is supervised fine-tuning. This is where the model is fed high-quality exploration traces, basically teaching it how to cast a wide net and gather evidence across multiple turns. But Stage 3 is where the real magic happens, reinforcement learning. They optimize it using a method called GRPO. It gets heavily rewarded for strict file and line-level accuracy and penalized if it gets sloppy or explores too wildly. That RL stage is exactly what turns it into the hyper-efficient 4 billion parameter powerhouse we just talked about. Which leaves us with one final thought for today. We've seen how single-agent setups waste up to 50% of their tokens just blindly reading files. And we've seen how splitting the explorer from the solver dramatically cuts costs while actually boosting final coding accuracy. FastContext is open source, lightweight, and totally ready to act as your ultimate sidekick. So the question is, are you ready to deploy the ultimate scout and stop polluting your agent's context? Thanks so much for joining me for this explainer. I really hope this helps you build faster, smarter, and cleaner AI coding workflows.